So let's talk about independence. So the definition of independence is an event E and an event F are independent if the probability of E given F is the same thing as the probability of E. So what does it mean for the probability of E given F to be the same as the probability of E?
1/2. E and F are equal.
No, this is weirder. This is a little bit like knowing that, this is like knowing that F happened, right?
Yeah.
So this is,
F doesn't affect E.
yeah, this is saying knowing that F happened doesn't tell you whether E happened more likely or less likely or not, right? Happens with the same probability regardless of whether I know F happened. Another way to say that is to say that F doesn't affect E. You guys see that? So, there's another characterization of this, which would be, or the probability of E intersect F is the same thing as the probability of E times the probability of F. You guys cool with this? I don't care actually which of these you take to be the definition of independence. They'll both work. This one is kind of the usual, but it doesn't really matter. You can take either of these to be the definition. So do you want to do a couple examples?
Yes.
See if we can figure out if things are independent? Okay, so are these independent? So I'm going to do a coin toss 3 times. So we're going to toss a coin 3 times, and I'm going to let F be the event that it goes heads, and then something, and then something.
Oh my gosh, I have no question.
Yes.
Well, I want to say the same thing.
Okay.
When I did this class before, we did this thing where we rolled a certain number of dice, I forget how many, and you have to get like a 1 or a 5 to win. It's like a probability thing. Is it?
Yeah, so that would be roughly answering a similar question. Yeah. So the events that I'm going to ask, right? The first event is heads and then something goes on. The second event is going to be I'm going to call this one E and this one F. So F is at least 2 heads. And G is going to be heads appear in 2 successive tosses. You guys with me? Okay, so I'm going to write out my sample space up here. So what's my sample space look like for toss a coin 3 times?
50 heads or tails. 50.
Yeah, they're either heads or tails, right?
Yeah.
So I'm thinking, alright, at the beginning, we toss, we either get heads or tails.
50.
Right? 50-50. Then toss again, we either get heads, heads, or heads, tails.
50.
And then toss again,
Tails, heads, or tails, tails.
tails, heads, or tails, tails. Why am I drawing the tree?
Thanks, Dick.
Because you're always right with the tree.
Yeah, because I'm always harping on the tree.
No, because you're always right with the tree.
Oh, because I'm always right with the tree. Yeah, most of why I'm drawing the tree is because I don't want to have to deal with which one did I forget in a second, right? So, at the top I've got heads, 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 then heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails.
Dang.
Okay, so now I'm interested in which of these are independent, right? So I'm going to look at E and F. So if I'm looking at E and F, how do I check to see whether E and F are independent?
Do they codependent on each other?
Yeah, I just want to know if they depend on each other, right?
Yeah.
So this is my check for independence. This is the thing I'm going to use to check for independence. I'm going to calculate these two things, or these three things. I'm going to multiply those two together and see if I get this one. If I do, I'm going to say it's independent. If I don't, I'm going to quit. Right? So I need to find first the probability of E. So
50%.
good. So the probability of E is 50%. 1/2. Probability of F is going to be a little harder.
At least 2 heads.
So at least 2 heads. So
Still 50%.
1, 2, 3, 4. Think those ones?
Still 50%.
So 4 outcomes in 8, which I reduce to 1/2. Okay, and then this next one's going to get harder because I need the probability of E intersect F. So that's the probability that heads came first, right? And there are at least 2 heads. So let me just figure out what E intersect F looks like. What's the chunk of my sample space for that?
So it has to be the top one. It has to be the top 2.
It can be either heads, 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 right?
Or heads, heads, tail.
Or heads, heads, tail.
Or heads, tail, head.
Or heads, tail, heads.
You got 8.
Which is 3 and 8. So the probability of E intersect F is 3 and 8.
Is that where you're ranking them fast and you want to say percentages?
Yeah. So then I'm wondering, is 3 and 8 the same thing as 1/2 times 1/2?
No. 1/2 times 1/2 is 25%.
Wait,
No,
A half times a half
No.
is 1/4.
25%.
Is 1/4 the same as 3/8?
You're done right there. That's it.
No. So E
I was
and
really so confident. I was like, yeah.
E and F are not independent. So then there's the question of how do you say this? And I think I prefer not independent.
Why don't you just say R dependent?
R dependent is also kind of okay. So let me try another one. So what's another one I could calculate?
What? What's
So are say F and
G?
G independent? So if I'm going to do F and G, right? I need the probability of F. So what was the probability of F?
2 heads. Oh wait,
The at least 2 heads?
50%.
It was half, I think. Right?
Yeah, and then that one's 3/8.
Okay, and then wait, what's 3/8? Oh, the one at the bottom? So heads in 2 successive tosses are this one, that one, and that one?
3/8.
So that's 3 and 8. So probability of G is 3 and 8. And then I need F intersect G. So which ones have heads in 2 successive tosses and also at least 2 heads? Oh, that seems dumb.
The same ones.
Yeah, it seems like if they have heads in 2 successive tosses, they definitely have at least 2 heads, right?
Yeah. Oh wait. Yeah.
You guys with me on that?
Yeah.
Oh,
Wait, did I miss something?
So the,
yeah,
Wait,
but just because that they have two heads does not mean that they have two heads in succession. So. You know what I mean?
so
yeah,
they're independent?
I know what
now?
you mean.
So,
let me see, so F intersect G, right, is heads, heads, oops,
Heads, heads,
how about
heads.
it's just actually equal to G,
That's true.
right, it's the same thing as G,
So 3/8?
you see that? So the
No.
probability of F intersect G is the probability of G, and the probability of G was 3/8? So are these independent?
No.
Why not?
Because if you multiply 1/2 and 3/8, it doesn't come out.
Yeah, 1/2 times 3/8 is 3/16, not 3/8. These are not independent.
Facts.
How does that seem obvious? If you have heads in two successive tosses, then you definitely know that you have two heads, right?
yeah.
Yeah.
You guys see that? So, knowing that there are at least two heads would kind of tell you something about G, or knowing that you had heads in two successive tosses would tell you something about F. Right, so these are gonna be dependent.
Yeah.
Okay, so let's try E and G then.
Can we make another one? Two heads?
Does it do something?
What do you mean? Oh, so hang on. What I came up with was E, oops, not E, F and G are not independent. So let me see the other one. So the other one was E and G. So the probability of G I just calculated. Probability of G was 3/8, right? Probability of E we calculated at the beginning was 1/2. What's the set E intersect G?
E intersect G?
Yeah, so what are the ones that have heads of the first toss and then have heads in two successive tosses?
Well, so that is only
Yeah, that's these two.
1, 2,
Just
that's it.
I think it's gotta be just these two, because getting heads of the first toss means that you're in these top four, right? And then the only ones that have two successive heads are either they're all heads or the two successive were in the beginning.
Yeah.
So you have HHH and HHT. So the probability of E intersect G is
Same thing as the other one, 3/16.
2 in 8. Is it quarter?
Yeah. No, doesn't work.
Not independent. What would two independent events look like? So what would be two independent events?
So it
all
has,
heads, all tails.
yeah, or the third toss is tails and it has at least one heads.
No.
No.
No? Dang.
How about the first toss is tails and the third toss is heads? You guys see why those would be independent?
Why?
So the event, the first toss is tails, right?
Yeah.
That's only about the first coin toss. The last toss is heads, is only about the last coin toss, right? So those should be unaffecting of each other. Right? Because the coin doesn't remember what it got before. Does that make sense?
So why would heads first and tails third be different?
Does it
Oh,
matter
they
what's
wouldn't
in
come
the
out with
middle?
different
Does
probabilities.
it matter what's in the middle?
They would be independent events.
Right.
Does that make sense? And it wouldn't matter what's in the middle.
Okay, so there's two.
Did I lose you guys
Well, yeah.
a little bit? So independent events are when the knowledge of one of the outcomes doesn't affect knowledge of the other. You see that? So if you know that you got tails in your first flip, what does that tell you about your third flip? Doesn't tell you anything about it. So those would be independent events.
Well, but what, like how I said, is if you got tails on the third flip and heads on the first flip, how would that not be?
That would be independent.
That'd be independent.
Yeah, I'm sorry. I thought I heard something else.
Okay, so it just mattered, well, with coin flipping, I feel like I wouldn't make any difference if it's heads or tails, like, or if it's independent.
So the thing we use.
Two options, and
the-
it's equal probability, right? Flipping?
Yeah, so what I'm talking about is not necessarily each individual coin toss, right? But the
So
events that
consecutive.
are a little more complicated than an individual coin toss.
Right, so consecutive would be, that would depend on the first flip. Right? As opposed to,
Yeah, so if I said tails in 2 successive tosses, right?
yeah, that wouldn't,
And then I knew that the first toss was tails. That's gonna make me more likely to get tails in 2 successive tosses because I know I already got one.
right.
Does that make sense?
Mhm.
Cool.